All right. Let's go here. All right. If you ever had a breaker trip before and didn't know why, or turned one off and something was still live, this stream is for you. I'm a licensed electrician and I'm going to break down real problems I see on job sites, not theory. Quick question. Type in the chat, have you ever turned off a breaker and it didn't kill the power? So have you guys ever turned off a round breaker? I've done it before. Many of us has done it before, where we have turned off the round breaker. And what happens when you turn off the round breaker is you kind of create a lot of problems. And when I say create problems, you kind of give your self more problems than it seems to be. Again, if you guys are tuned in here on Instagram, whoever is tuned into Instagram, you can click, don't forget to like up the live stream. You can also join me here over on YouTube at my YouTube channel. For whoever is over on Instagram and whoever is on YouTube, don't forget to like up the live stream. Please and thank you, very important. And again, round breakers turned off, it happens all the time. Why do round breakers get turned off? A lot of times it's not labeled properly. You don't know the correct, the correct breaker. You're assuming, you're guessing. You go to the panel, you flip any and everything, and again, that alone will cause a whole lot of issues. So you don't really want to guess when it comes to breakers. You want to make sure that you have it down packed. Very important. Um, and that's where you can also injure yourself. The breaker is obviously still on, and you're not aware of that. And when the breaker is still live, it obviously causes issues, shock issues, and so on. Again, try to avoid that. It can be very dangerous. So again, I hope whoever is over on the Instagram can hear me here. And again, I'd like to thank you guys all for tuning in to tonight's live stream. Again, don't forget to like up the live as you guys come in. Close calls. A lot of times we get a lot of close calls. I've gotten close calls. It happens a lot of times in also commercial where you get close calls, sharing neutrals and so on. Happens to be that the breaker that you thought you turned off is still on, or the neutral for the other breaker is still on. That's what happens when you share neutrals and you get a lot of close calls. So you want to always avoid that. Um, Again, this is obviously where people get hurt. They trust the panel. Me myself, I don't trust the panel. Reason being is because I don't know who was there before, and if it's not me that did the job, I go into it as assuming that I don't trust what is in that panel. So I take extra precautions when it comes to the panel. So trusting the panel, you have to be very, um, you have to be very careful when it comes to trusting the panel. You have to make sure that you know the work was done correctly. So trusting the panel is, again, something that you want to make sure that you're always aware of. Again, for all those who are tuned in on Instagram, don't forget to give the live stream a like. Also, for all those who are tuned in on YouTube, don't forget to like the live stream, please and thank you. It does help with the channel. It helps to push the live stream out to more people. So again, that was a little bit of, some real job experience that I've encountered on the job itself. Always avoid those mistakes, and we're going to get into why breakers trip. For all those who are tuned in, we're going to get into why breakers trip, and again, why breakers trip. Breakers trip for many different reasons. Overloading is one of them. When you overload your circuit, for instance, you take a couple of your heaters, a fridge outlet, and so on. You install it on that circuit. You've now overloaded the circuit, and it's going to obviously trip because it's not the proper size breaker that you've used. So when you are overloading the circuit, that's what happens. You're basically going to have breakers tripping, and I'm going to put it up here on the screen so you guys can see what I'm. So this segment right now is why breakers trip, and we're going to get into it a little bit more. Why breakers trip. Again, for all those who are tuned in to the live stream, don't forget to give it a like. Very important. And again, okay. So breakers. Why breakers trip? Overloading too much on one circuit causes that. Too many people assume that breakers can go on any size wire, and not just that. When mixing different load, it becomes an even bigger problem. So why breakers trip? Breakers trip for the simple reason you have two sets of breakers here. One is a 15 amp, one is a 20 amp. As you can see, 15 amp and a 20 amp. And what happens is a lot of people will mix these breakers up. So it's very important not to mix your breakers up. Very important. As you can see, I have a 15 amp breaker here, and I have a 20 amp 2-pole breaker. So it's very important not to load these breakers the wrong way. When I say the wrong way, I mean that if you have a number 12 gauge wire, make sure you use a 20 amp 2-pole, depending on if it's a AC unit, if it's a heater that calls for 2-pole, all depends on what it's called for. If you have a 15 amp, most 15 amps are used on your lighting circuits and so on. So pay attention to that. Very important. So again, overloading too much on one circuit causes that. Too many people assume that breakers can go on any size wire, and not just that. When mixing different loads, it becomes an even bigger problem. And again, when mixing different loads, pay attention. You want to pay attention to what that unit is drawing. Let's say you have a microwave, let's say you have a kettle. You want to make sure that you have the correct circuit for the equipment itself. You don't want to overload. That's why your breakers trip. Again, And short circuit. What is a short circuit? Um, Short circuit plays a very important role of how your circuits will short out. Again, when installing wire into boxes and through joists, you should pay a lot more attention. A lot of people are not aware of that. When pulling your wires through the joists and so on, your wires can get nicked. And if your wires do get nicked and they're touching against metal or whatever it may be, it is going to cause it to short out. So that's the meaning of short circuit. Also, what short circuit means also is if you have if you have a metal box and you are, I don't have a box here, but if you have a metal box, it's normally a roughing box we use for your receptacles and so on. Boxes you use in the kitchen. Sometimes they're plastic, sometimes they are metal. Plastic ones we use on the outside walls for the water resistant. So again, metal boxes, when you do roughing your boxes, your wires into the box, if the wire is nicked, if your wire is nicked, is going to cause an issue. It's going to hit the box and it's going to short out, and that's where you're going to have a lot of your shorts from also. So again, pay attention to that. Very important when it comes to that. Paying attention to your short circuits. You want to avoid that. Um, so again, um, when entering boxes, that's when you're more likely to short your wires out because of nicks on the wire and now touching the metal boxes. And you have also what we call fault current, arc faults, ground faults. When using your GFI for your washrooms and kitchen, make sure to have it connected properly. Also make sure that when having separate runs, not to mix your neutrals up. It gives a pick up other neutrals and gets confused. So again, separate runs. Be aware not to mix up your runs because of the neutrals. When you have different neutrals on an arc fault, it's going to give you a nuisance trip. Reason being, it doesn't know the correct neutral path to return on. It's having to think about the two neutrals that's on the arc fault itself. And again, that has happened on job sites where I have seen that. So that becomes very a nuisance for troubleshooting also when it comes to that. So um, pay attention to that. Very important. Um, too many heaters, too many heaters on one line can give you too many heaters on one circuit also can also give you issues of shorting out. There is a correct way of doing that. If you have two heaters, you can simply increase the load. When I say increase the load, you can simply, let's say you have two heaters, they're both drawing 15 amps. You can simply bring in a 30 amp circuit for that, and you can simply wire it up like that with a 30 amp breaker respectively, or according to what the code book allow us to use as a breaker. And you can simply make your connections in the junction box and have both your heaters turned on accordingly, as long as you have them loaded for the correct breaker size. So if you have two heaters, like I said, you can load it for the correct breaker by simply upsizing your breaker according to the calculations in your code book. I believe 15 amps. Let's say your heaters are drawing 12 amps and 12 amps respectively, or 10 amps and 10 amps respectively. Then you need to simply, that's 20 amps of users. You have to go to about 30 amps or so. There is no 25 amp breaker, so you have to go to the next breaker up. And again, that's how you normally will size or heaters and so on. So pay attention to that. Again, too many heaters on one line, that's an overload, people. Uh, who here has a breaker that trips when you plug something in? Okay, so I'm going to put up the next segment here that I'm going to for all those who are tuned in to tonight's live stream. You're tuned in to Fabian Electrical Services Inc. Again, as you guys enter, don't forget to like up the live stream. If you are on Instagram, don't forget to give it a like. If you are tuned into YouTube, also don't forget to give it a like also. Okay, so right now I'm going to put up the banner of the next section I'm going to go into here. Again, excuse me here, guys. I'm working off of my cell phone and my laptop where I am pulling up certain stuff here. Um, However, the laptop is booting off the live stream. That's why you see me trying to play around with the laptop here. So let's show this one here. Okay, so big mistakes people make. Big mistakes people make. Um, Wrong breakers. You know, I see it all the time on the job site. Round breakers. What happens is, sometimes you install, let's say you have a Snyder breaker, for instance, and you have a Scrady breaker. What happens is some people will try to install, well, I cannot use a Scrady because it's not going to work. If you guys know of a Siemens panel and an Eaton panel, I don't have that breaker here. They're both the same type breakers. They both look the same. What happens is a lot of times you will swap out breakers in different panels. Siemens and Eaton carry the same panel, carry the same breakers, look alike, but different names. And again, you cannot do that. As you can see, there's names and so on the breakers. There are writings on the breaker. Um, Doing that voids the warranty. You can obviously um, have issues if there is a big issue that's going to happen. So installing any type breakers into the So again, installing any type breakers into the panel, inspectors will fill the job. You can't just put any breaker into any panel. It's a violation. It's a big violation, guys. Um, Mislabeling of panels. A lot of times you're going to a job and you will see that a lot of times you will have, for instance, your washroom is labeled on that breaker, but for some reason your lighting circuit is not on there. Maybe your outside receptacles on older homes, that's how it goes. It's not on that also on that breaker. So that can lead to issues. That can lead to short hazards also, because the person doesn't know that the breaker is still on. Um, and also mislabeling. Mislabeling also is a big one. Also, um, saying that your bedroom circuit and your lighting circuit is on the same circuit, but when you do check, they are not on the same circuit. So mislabeling is a lot of times you see it in homes. Again, a lot of times people don't remember to put everything that's on that circuit that was turned off. Circuits on the correct breaker, and it causes problems. And what happens when it causes problems? You take more time troubleshooting. You're troubleshooting constantly, trying to figure out why isn't this circuit going off, not knowing that the circuit is not really for that circuit. Your lighting circuit is not really for the circuit that you turned off. Again, that's a lot of times you see those mistakes in homes. Causes issues, troubleshooting. You have to go around and troubleshoot. You have to take extra time to figure out where this is going, what neutrals it's sharing. Again, avoid sharing neutrals in homes. Um, so that's another issue that you run into. Also shared neutrals. Sharing circuits in residential is never it's never really a good idea. Um, why is it never really a good idea? Reason being is when you share neutrals in residential, you have a lot of arc faults that you use in residential, and that neutral can send back a bad signal to the arc fault. The arc fault doesn't know what to think. It's got two neutrals on the same circuit, two separate neutrals. That's doing two different things, and it's going to cause the circuit to trip constantly when you are using a vacuum and so on. It's going to pick it up. So avoid using or sharing neutrals in residential. Normally, I don't share neutrals. What I normally do is I will pull in my plugs, receptacles. I will pull in my kitchen circuit separately. My lighting circuits I will pull in separately. So as you can see, nothing is being shared with anything else. Again, um, shared circuit is never a good idea when it comes to residential, but commercial is totally different. The three-phase system for commercial allows you to share neutrals accordingly. When I say the three-phase system, so in commercial there's something called a three-phase system. It's red, black, and blue. that you use. Coming off of the step down transformer, step your power down, and what happens is you're now allowed to share your neutrals. It's 3 lines that you have. What it is it can go from 135 or 246. 135 is simply red, black, blue. Red, black, blue allows you to share neutral on that same line. 246, or it allows you to share neutral on 135 on the same side of the panel accordingly. If you are looking at the panel like this, you have one side is your panel. You cannot cross share circuits. You have to stay on the same panel side in commercial. That's how you normally do it. And again, in the United States, it's called OBJ. That's how they classify it as and identify it as OBJ. So again, this is why guessing will get you shocked, guys. Avoid guessing circuits. Guessing circuits causes issues, and again, it will get you shocked. It will give you the surprise of your life. For instance, if you are working on a panel and you are sharing neutrals, let's say, for instance, you're touching the ductwork and you think you've turned off that neutral that you are working on. However, that neutral is being shared with another circuit. That can cause serious issues. I've seen it on job sites before. So again, pay attention to that. Sharing neutrals is very, very, very can be very dangerous if you don't know what you're doing. Also, when it comes to sharing neutrals, you have to know to troubleshoot when it comes to the commercial. You don't want to start sharing neutrals and you don't know what you're doing. You have to recognize that if you share 1 and 3, both those circuits has to be off. What I mean by both those circuits, 1 and 3, if you're sharing the neutral with 1, 3 or 1, 3, 5, you have to shut all circuits down. If not, your neutral is still going to be live on the other circuit, and that's when you're going to get a zap, guys. So very, very important when it comes to sharing the neutrals. So again, right now we're going to go into tools and how I go about testing, guys. How I go about testing my circuits. So I have multiple testers here. I'm going to be showing you guys tonight. So how I go about testing. This is simply one of the testers I use. It's a ideal tester. It's a plug-in tester. Again, you can see it's got 120 volts AC GFCI. It's also got the 3 dots. As you can see, it tells you if your circuit is correct. It tells you if your circuit is wired wrong. It tells you if it's a hot and a neutral. It tells you everything here. Open hot, open ground, open neutral, so on, hot on ground and open no ground. So this is one of my testers that I use on the job site. It is a plug-in tester. So again, you simply turn it on and you plug it into your receptacle, and it's going to show you the correct one. It's going to tell you if it's on. It's going to tell you if it's dead. This is one of my testers that I use. Again, this is an ideal tester, plug-in tester. And we're going to go on to one of another tool tester that I use. And this one is a different brand that I use. For all those who are tuned in to tonight's live stream, if you are tuned in over on Instagram, don't forget to like up the live stream. For all those who are tuned in on YouTube, don't forget to like up the live stream. Also helps with the channel. And what we have here, we have another plugin tester here that I have here. This one is the actual Kiwi brand that I've been using on job sites here. And again, what this does is it's another tester that I use, another plugin tester, form of a plugin tester that I use, guys. Again, what this does is you plug it into the actual wall itself, and you turn it on, and it's basically going to have the on button here. This here is your receiver. You go to the panel, you scan. This will light up red when it comes on, when it's the right breaker that is found. Again, these two work hand in hand. It's a Kiwi brand tester. This is the transmitter itself, and without this is not going to work. Vice versa. Without this is, so they both need to work in hand. So I'm not going to stay too long on this tester because I have a couple more that I do want to show here. And what we have next, what I like to use on the job sites, I don't just rely on the plugin testers. Again, guys, I don't just rely on these plugin testers, okay? I also don't rely on this tester. What this is simply you turn it on and it detects power. However, it does give a false reading a lot of times. When I say false reading, again, sometimes you might think the power is on, but the power is not on. And again, this is just a regular tester we use to see if there's power, to see if there's anything there. It's not a go-to tester, guys. I don't rely on this tester to save my life. This is the tester that I rely on. So again, this is a fluke tester. This tester actually carried over 20 years now, believe it or not. I've had this tester from I was an apprentice, and I still have the tester actually. I don't, I have another tester that I use also, but this here, as you can see, it's got different categories. It's got category 3 in the corner there. As you can see, category 3, it's got up to 400 amps. It's got up to 300 volts. Again, why is this important? This is important because the higher the voltage you go, the different category you need for testers. And again, this is up to 400 amps, it says on the tester itself. It's a category 3. So let's say you're going up to maybe 600 volts, 600 amps. Sorry guys, this, I cannot use this for 600 amps. It doesn't say on here. This is where I stop. This is 400 amps. So I'm obviously not going to use this on a 600 amp service. And again, it's very important. this is my go-to tester on a job site. This is what I will test to identify true power on the job site on my circuit. This is what I'm going to check to see if I have open ground, open neutral, and so on. You can use this also. You just have to know how to use the meter. Right now it's in the off position. If I turn it on, as you can see, that's where I will test for my continuity to make sure that my wire is not broken and so on. That's how you run out your wires. Make sure your wires are good. Make sure your circuit is good. Make sure there's no nick wires and so on. So this is the go-to tester that I use. It's a fluke tester. I've had it for many years, so it is time to get a different tester. I do have another tester here, but I'm not going to show you guys that. It is a different kind of tester. It's a masterclass actually. So again, it's not how you use the tester, it's who's behind the tester and who knows what they're doing. So if you are someone who are very cautious of your circuits and you know how to use your meter, then it doesn't matter what type of meter you have. You just need to have the proper category meter in order to get the job done. Again, as you can see here, this is simply your voltage sign here, 600 volts, you've got that there. You've got also 600 volts to ground. You've also got 40 amps, 400 amps. So these are the settings that you will use on these on this meter. So this is one of the testers I use again to identify and shut my circuits down, or to make sure that my circuits are off. Again, always pay attention when you do have your meter. You want to make sure it is the correct meter. So this is a fluke tester. Again, I've had this tester for many years, and it is still in good standing. As you can see at the back here, you have the UL standard. So you want to make sure that you have that on the back of the tester. Make sure that that sticker is on there. It allows you to test without having that doubt that your tester is going to go on you. So another tester that I have also, I've got many testers, guys. This is simply a masterclass tester. Again, this is another type of tester I have. It's not my go-to tester. Again, it's a masterclass. There is nothing wrong with it. It does have the same thing that I have on that tester. It does tell you 600 volts. It does tell you category 3 on here. So you have category 1, category 2, category 3, category 4. I think category 5, but I don't remember. I'm not 100% sure. And again, you're going by the categories. You're going by the voltage up here of what you need. And again, you simply have continuity. This is continuity here, and so on, guys. That's how you ring your continuity here. Again, this battery is dead, so I'm not going to be able to turn it on to show you guys the functions, but it is the same thing as the other tester that I have there. There are many different multimedia testers that you can use. You just have to know what you are doing when it comes to the testers, guys. So type yes if you've seen this before. What's stripping in your house? Um, who here is dealing with that right now? You can drop your comment in the comment section. I am going to try to try to run a video here for all those who are tuned in to tonight's live stream. Try to change it up here a little for all those who are tuned in. If you are tuned in on Instagram, don't forget to give the live stream a like. Also, for all those who are tuned in on YouTube, don't forget to like up the live stream. Very important. Helps with the channel. Okay, so I'm going to do this off of my phone here, guys. I'm going to run a short clip here. Good night, Tim. Thank you for tuning in to the live stream. I didn't realize that you checked it. So again, for all those who are tuned in, I'm going to run this video here. Again, this is about breaker sizing. So what this is simply me installing the panel, and again, the importance of having your circuits labeled correctly is also to reinstall them on the breakers themselves. You don't want to mix and match wires. You don't want to put any wire on any breaker. So you want to make sure that you have the correct breaker. So this is how I normally go about installing the panel. Also how I normally go about installing my wires on the breaker. Very important, guys. So again, for those who are tuned in to tonight's live stream, don't forget to tap on the like button to like up the live. Helps with the channel. So again, for those who are tuned in, this is how I normally go about installing my panel and sizing my breakers accordingly to avoid any overloading of the circuits.
that's another exciting video. Also, please like, share, and comment. Um, and stay tuned for the next video. Thank you.
Okay, again, thank you guys all for tuning in to tonight's live stream here. I am going to be doing a Q&A right now for all those who are tuned in. I will continue to also play some videos for the night before I log off the live stream. So again, this is live Q&A, and again, you can drop your comment in the comment section if you feel the need to tonight. Again, so again, if you're not sure, just describe your issue. I'll break it down tonight. Again, I'd like to thank you guys all for tuning in to the live stream. Also, I'd like to thank Kim, Wifey for Life, for tuning in. Antonia Whitaker for tuning in to the live stream. So again, this is live Q&A. You can drop your questions. I'm here. I'm going to answer them live tonight. I will play some videos while I'm here for the rest of the time. So you can just go ahead, drop a comment. If you have any comments about electrical, if you have a trip breaker happening, you can drop it in the comments section. Also, guys, for all those who are tuning in, don't forget to like up the live stream. Helps with the channel. So again, for those who missed the live stream at the beginning, you can catch it on the replay also. You can catch the tools, what tools I use on the job site in order to protect myself. I don't just guess. I use a variety of different tools to get the job done correctly. Also, tools that I know that will save my life. Very important to always remember that. So I'm going to run another video here, guys, for all those who are tuned in to the live stream tonight.
Hello and welcome back to the channel. And for all those who hasn't subscribed to the channel, you can go ahead and subscribe to the channel. Make sure your notification is turned to all. That way you can receive my content. And in today's video, what we have is I'm prepping for a service change panel swap out from 100 to 100. And this panel is an old panel that is defected. So again, I will be changing out my panel, and I will be following all ESA, electrical safety code. So again, like I said, please sit back and enjoy the video, and I will see you guys at the end of the video.
So again, thank you guys all for tuning in to today's live stream. Again, as you guys enter, don't forget to like up the live. Helps with the channel. So again, what this is a service change. As you can see, I'm removing the old panel itself, and I'm going to be reinstalling a new panel in this location. So it's a very tight spot, and again, I can only work with what I have. Also, following the code rules of reinstalling the correct panel at the same height that I had before. So it's very important to follow the code rules. So again, for all those who are tuned in to tonight's live stream, don't forget to like up the live stream. Very important. Uh, So again, this is live Q&A. If you guys do have a question that you guys want to drop, you can drop it in the comment section. I will answer your questions live tonight. So what I'm going to do here also is I am going to, let's see here. Let's see if I remember how to do this here, guys. It's been a while here. I will okay, so let's try this again. Let me run one more video here, guys, for all those who are tuned in. This is a live Q&A tonight. You are live tonight with Fabian Electrical Services Inc. I'm Fabian, so you can drop your questions tonight. And what I'm going to do here is I'm going to drop the link, guys, for all those who wants to call in. You can hit on the StreamYard link there. If you guys want to call in and have a question about electrical, you can call in on the live stream also. I'm going to run a video here. Okay, hello and good morning to all my subscribers. Please like, share, and subscribe to the video. I'm basically going to be prepping for my service 400 amp panel.
Please, hello and welcome again. Please like, share, and subscribe. This is basically my 400 amp panel, which I removed all the components from inside, switching out the panel. You can see this is panel covers that I had to remove in order to mount the panel on the plywood.
So again, hello and welcome back to the channel. I'd like to thank you guys all for tuning in to tonight's live stream. Again, as you guys enter, don't forget to like up the live stream. I'm going to run a couple more videos before I do log off the live stream tonight. Again, for all those who are tuned in, if you're new here, you can don't forget to subscribe to the channel. Stay up to date to my weekly content. Also stay up to date to my live streams that I normally do once per week here also. So again, for those who are tuned in, this is simply the panel that I am installing. Again, thank you guys all for tuning into the live stream tonight. So again, guys, for those who are tuned in to the live stream, this will be the last video I'm going to be
So this has the marking to get the where it's going to land. basically it for today's video. So please like, share, and subscribe, and also leave a comment in the comment section, and I will see you on the next video with this installation. Thank you.
Okay, so that is the last video I'm going to be running for the night. Again, I'd like to thank you guys all for tuning in to tonight's live stream. I'd like to thank Kim for checking into the live stream. Also, Antonio Whitaker for checking into the live stream. And again, for all those who are tuned in for the first time tonight, don't forget to subscribe to the channel, stay up to date to my content. You can also for all those who catch the live stream on the replay, don't forget to give it a thumbs up. And again, I will catch you guys on the next live stream.